Welcome back to the Kielder Observatory Podcast, the first of 2021. I'm Ian Brannan. I'm joined by science communicator at Kielder Observatory, Dan Pye, and we're going to have a look at what's coming up both at the observatory over the coming month. A little spoiler alert, not a great deal, what with lockdown, but there are ways that you can get involved with Kielder Observatory wherever you are, not only in the UK, but around the world as well. We're also going to be speaking to Hayden Goodfellow about an exciting project the UK is involved in with putting a lander on Mars. The project is called ExoMars. The idea is to try and find signs of life on the red planet.
I'm very optimistic that within the next few years, the results from these rovers is going to come back and we are going to discover that we are indeed not alone.
First though, let's have a look at what's happening at Kielder Observatory at the moment. As we mentioned, not a massive amount, what with lockdown, but the work does continue. There's ways that you can get involved via social media, and there's plenty of things that you can look out for in the night sky over the month of January and into February as well. And joining us to explain more is science communicator from Kielder Observatory, Dan Pye. So Dan, you've still got plenty on your plate to be keeping you busy, even if there's no public allowed in at the minute, but you've got lots on.
Yeah, that's it. Actually, we've even been going up during this snowy time that we've had. It was thick of snow the last couple of weeks at the observatory, but Dan, other Dan, trekked up the track, 2 miles up the dirt track, walked all the way up there just to switch on the telescopes and get some stuff that we needed to capture. So yeah, we've still been going up there and capturing things. And making sure that the kit's okay. We've got a new mouse which has moved into the 16-inch observatory. Being in the middle of the forest, this is just the things that we have to put up with. I guess we invaded their territory, so now they're invading our building, which is fine. Because
of the lockdown, obviously people can't come and visit you. What is the situation with that? Is this just with everybody else, really, you're sort of waiting for further government announcements? I mean, what's the threshold for you to be able to get back open again?
That's it. We close as soon as the government give us some kind of time frame as to how long the measures are going to be in place. We automatically cancel events up to that date. At the moment, that's the 15th of February. So everything up to the 15th of February right now is cancelled. Anything beyond that isn't yet cancelled because obviously we don't know what's going to happen beyond that date, and it might get quite close to the line before we make those announcements, because we'll be doing that in line with the government guidance. Once we get to Tier 2, that's when we can reopen again. So Tier 2 for Northumberland is when we can reopen our doors, and that's when indoor entertainment, which is the category that we come under, even though a lot of the stuff that we do is outside, we still have some indoor activities. So we have to abide by the government guidance that we can't open until we're in at least Tier 2.
So Tier 2 is the level we're reaching for. In the meantime, how can people get their fill of Kielder Observatory online? Because you've been doing some live streams as and when the weather and staffing permits. What have you discovered when you've done your live streams over the previous few weeks?
We have, and they've been really great, actually. We've been hosting those on Facebook, so we usually do that as a Facebook Live. We usually post that information on our Instagram and Twitter feeds as well, just to notify people that we're going to go live on Facebook. And then if you hop over to Facebook, we'll go live there as and when we can. There's no real set pattern to that. It's just when it's nice and clear, and like you say, there's available staff to do it. But we've looked at some incredible things. We've looked at Mars. We were able to see a couple of months ago, we were able to see some incredible surface detail on Mars as well. Some of the canals on Mars, or of course they're not canals, but some of the surface features of Mars that we're able to see through our telescopes. We were able to look at the planet Jupiter. We've been able to look at Saturn and of course the conjunction. Although we didn't get the actual conjunction itself, we still managed to get some great shots of it just after the conjunction. And of course the moon, everybody's favourite satellite, the moon. We've done some really good exploring around different features of the moon, different craters. This line, the divisional line between the light and dark side of the moon that we call a terminator, such an ominous name. For such a beautiful region as well. It brings out some incredible contrasted detail on some of the craters that we see on the surface of the moon. So we've been looking at all of that, and even things like star clusters as well. And hopefully, if we get to do some really good observing on a really good dark night with no moon in the sky, we'll be able to see some stuff such as galaxies and maybe even clouds of gas as well, nebulae and stuff like that.
Looking to the night sky over the next few weeks or so through January, what can people look out for? It was all about the great conjunction with Saturn and Jupiter leading up towards Christmas time. Now I understand that those planets are moving further apart, but in the night sky in the evenings we can also see Mercury joining in on the act as well.
Yeah, that's it. Mercury's starting to reach its greatest eastern elongation, which it'll start to approach in the early stages of February the 10th, I think it is when it reaches its absolute greatest eastern elongation, which means Mercury is going to be rising higher in the sky as the night goes, or as the evenings progress, and it'll be at its greatest distance from the sun on an evening, moving up to the 10th of February. Joining in the planetary party.
Yeah, it's all happening. And what other things have we got that we can look out for around this time of year?
There's some incredible stuff to see in the sky at this time of year, because now we're starting to see some of the fainter objects start to rise in the evening and into the midnight kind of territory. So stargazing at this time of year, we get to see a complete contrast of stuff that we get to see during the summertime. We get to see all of those really, really faint, really, really distant galaxies with our telescopes and with back garden telescopes as well. It's an opportune time to start to do some of that really distant stargazing if you have the instrumentation to do so.
And that brings us very beautifully onto our Pie in the Sky section, where Dan Pie gives us an object that we should be looking for in space over the next few weeks, just using binoculars or a telescope. Dan, which direction is your telescope pointing in this month?
If it was me, I would be pointing my telescope or binoculars towards the constellation of Auriga. Auriga is a pentagon-shaped constellation. We often, I like to refer to it, and I stole this from Becky, who used to work with us at the observatory. It looks like an upside-down cupcake, but in fact, it's a charioteer. So it's just above Taurus the Bull. In between Gemini and Perseus is Auriga, and there's a very bright star called Capella within it. So you should be able to locate it in the night sky with great ease. And in fact, actually, it's right above Orion, so it's dead easy to spot. So if you look within Auriga, right in the central part, there's lots of these clusters within Auriga. These are open clusters. So they're a cluster of stars which are relatively close to each other, and they'll form a shape of very closely bound stars from our perspective on the rest of the Milky Way. This particular one's 4,500 light years away, and it's filled with hundreds of stars, somewhere between 100 and just over 100 stars or so. And it's supposed to look like a starfish, so we call it the starfish cluster, or M38, right in the centre of Auriga. You can see it very close by. We've got some other little objects as well, M37 and such. And you might notice, just if you didn't already know, that the designation for these as M numbers, this comes from a catalogue called the Messier catalogue. Charles Messier was quite a famous comet hunter. He was looking for comets across the night sky, and when he was searching for comets, there was objects which were catching his eye, which weren't comets. They were stationary objects. They didn't appear to move. And of course, comets move through our solar system. And so he thought, I'll make a catalogue of all of these different objects, and these made the bar as objects which looked like a fuzzy blob or something which would otherwise distract you from looking for other objects. M38 is an open cluster, also known as the letter pi cluster. And of course, pi being my name, that makes me instantly drawn to it as an object that I would look at.
So you're not biased in any way?
Nah, not biased.
No,
anyway.
Doesn't sound like it. Very good. So look out for the Pi cluster, and that's one that you can check out just with an ordinary telescope or a half-decent pair of binoculars, and something to look out for in the night sky over the next month or so. Next on the Kielder Observatory Podcast, we turn our attention to a planet that we've spoken quite a lot about over the past few months because it's been very visible in our night sky, the planet Mars. It's a planet that's often had wonder of whether life existed on it. David Bowie wrote songs about it, and a new mission is going to try and answer that question once and for all as to whether life has actually ever existed on Mars. That's certainly the aim of ExoMars, which is a program that's already underway. The first part of it launched in 2016. The Trace Gas Orbiter is currently going around Mars and analysing the atmosphere, what there is of it, to see what sort of gases it can find. The second part is a collaboration between the European Space Agency and Airbus here in the UK, where we are creating a rover, a British-made Mars rover, which is going to go around the surface of Mars and actually do some quite deep drilling to see if it can find any evidence of microbial life and answer that question, if there is life on Mars, or indeed ever has been. Joining us to tell us more is Hayden Goodfellow, one of the team at Kielder Observatory, currently in training to be a physics teacher, but a keen follower of exploration of life on Mars, and a keen follower of the ExoMars programme as well. And he's actually seen the Rosalind Franklin lander, which is the lander that they're hoping to put onto the surface of Mars, to tell us more about this programme and maybe what life would be like on Mars. Hello, Hayden.
Hello.
So tell us about this then, because you've actually seen a mock-up of this lander. I mean, how exciting is this for not only British space exploration, but also for European space exploration as well, to get our own lander on Mars?
It's massively exciting. If the rover does successfully manage to touch down on the surface, it'll be, as you mentioned, the first successful soft landing of a machine on the surface of Mars by a European country or European agency. There have been 2 attempts before, as far as I know off the top of my head. The first mission to touch down on Mars from Europe was the Beagle 2 mission, which did successfully softly touch down on Mars, but we didn't know that until many years later when the Mars Reconnaissance Orbiter managed to capture images of it sitting on the Martian surface, astonishingly not in a million pieces. Beagle used a strange design where the antenna for communicating with ground control was folded up inside the rover's inside the lander's descent module, and it didn't unfold on landing, so it couldn't communicate to the Earth and say, "Hey, I'm landed, I'm fine, I'm taking measurements." There's a very good chance that the UK has done science on the surface of Mars, and we're just waiting for it to be picked up by some astronauts. The second attempt the European Space Agency made to land on the surface of Mars was actually during the first phase of the ExoMars mission. They launched an orbiter to the surface of Mars called the Trace Gas Orbiter. That's been scanning the Martian atmosphere looking for signs of biosignature gases. And because they had a bit of spare payload capacity in the rocket, they put a lander in with the orbiter. And that lander was called Schiaparelli, and it would test the entry, descent, and landing system that would ultimately be used by the ExoMars rover, as it was then known. Unfortunately, it crashed. So if the ExoMars rover, and now called the Rosalind Franklin rover, does successfully touch down, it'll be the first successful soft landing by Europe on the Martian surface. I believe only NASA has successfully landed stuff on the surface of Mars softly.
I know that looking from both the European Space Agency websites and Airbus themselves, because Airbus are the people who are behind constructing the rover in terms of the mechanics of it, that there has been a lot of research go on into the landing phase and testing parachutes and trying as best as they can in our atmosphere, because obviously that's the big difference and that's the unknown quantity. And I think it's probably a good idea to try and, if they could, have a practice, because it's very difficult to replicate those conditions, I suppose, isn't it? We can replicate the rock and the terrain, but not so much the atmosphere.
Yes, the atmosphere on Mars is, I sometimes describe it as annoyingly thin. It's about 1%, just under 1% the atmospheric pressure of the Earth at ground level, which means it's thin enough that parachutes don't really do a huge deal to slow you down. You can use a parachute and still be doing 200 miles an hour because there's just that little resistance offered by the atmosphere. However, 1% of the thickness of Earth's atmosphere is thick enough that if you try to ignore it, it will disintegrate the spacecraft. So having practice runs trying to get this right, it's incredibly difficult. It relies very heavily on simulations. And then once you get down to Mars, you have arguably less of a problem, but still a problem, in that, yes, you can make replica Martian soil on the Earth. You can put big boulders on for the rover to try and drive across. But Mars's gravity is only about a third of the Earth's. So the rover weighs, it's pushing down on the terrain on the surface of Mars with 3 times less force than it would be on the Earth. And so how they got around that, and this was something that fascinated me, they build several prototypes. And the rover prototype for testing out the traction system actually weighs less than the final rover will do. It's designed to have the same downforce on the soil that the final rover would in the lower Martian gravity.
And this, of course, is the search for previous life on Mars. Looking further down the line, the hope is to get humans and man onto Mars in some form. What are the realities of that? Because Mars is not the most comfortable place to be living. Very thin atmosphere, as you've mentioned. Human life can't just walk out there and get going. What are the realities for those people that are going to be living there? Because it's not the most welcoming of environments.
Oh, yes, definitely. We've got a lot of practice, though. We've had the International Space Station has been continuously occupied by rotating crews of astronauts for the last 20 years now. We have sent people to live down in Antarctica, also a very, very inhospitable place for months and months at a time.
Mm-hmm.
And the one thing that the space agencies really try to do when they're sending people to go and live in these harsh environments is keep them busy.
Yeah.
The astronauts have an awful lot of work to do on the space station, and they will have a lot of work to do on Mars. It might actually be more on Mars because you have to deal constantly with the radiation from the sun. Having a surface settlement means it will naturally be likely larger in terms of internal volume than the International Space Station. So there'll be a lot of work to do maintaining it, upkeeping it. Getting out for a walk would not be too difficult, I don't think. They'll have an airlock, but again, using these airlocks requires energy. And that's something that will likely be in short supply. They'll have solar panels and batteries likely for power. NASA are suggesting sending some form of nuclear generator to Mars. They have they've been building prototype nuclear farms to harvest nuclear power as well as solar power. I think ultimately powering the civilization is going to be something that's decided by whoever gets there first. And I suspect it'll be NASA. NASA and the European Space Agency working together. I don't think SpaceX, who are the other people aiming to get to Mars, to send astronauts to Mars, so SpaceX don't have the capability just now to build their own launcher, their own lander, and all of the ground level infrastructure that's needed to set up a settlement on Mars. They are coming from way, way behind NASA, further behind NASA than a lot of people, including Elon Musk, would care to admit.
And with SpaceX, they've been working in partnership with NASA in the stuff that they have had success with in terms of putting people in space. So, they are working alongside them rather than in competition with them, which I suppose if they were going to get something set up on Mars, they would be going in competition with NASA. So it's a much different prospect.
I'm not an expert on space law at the moment, but the plans SpaceX are releasing for how they want to send people to Mars, what they want to do there, the type of governance structure that they want their eventual Mars city to have, is worrying quite a few people in the space community.
On what level?
They're being a bit more gung ho. There is the United Nations Charter on the Peaceful Uses of Outer Space. This was a document that every country in the world has signed up to, basically stating that they will not store nuclear weapons or do nuclear tests on any body other than the Earth. No individual nation can claim ownership of land that is off the surface of the Earth. SpaceX seem to have this attitude that if they get to Mars, they will be allowed to make their own rules there.
Wow. So Elon Musk is basically, it's not Elon Musk personally, but SpaceX, which is his company, sort of think that if they get there first, then they own Mars.
Not necessarily all of it, but I think the bits that they mark out is, right, we're going to put our civilization here, and we are going to have our own government.
Blimey, it's getting a bit Star Wars, that, isn't it?
The governing structures. Again, I'm not a constitutional lawyer either, but there's a bit of worry going around. So in terms of a timeline for settlement, I would be very surprised if anyone has set foot on Mars by 2030. I would be even more surprised if anyone hasn't by 2040.
Wow, so imminent action really in the scheme of things for the exploration of Mars. And of course, it has been going on for a little while. The next one is going to be one that we're involved in the UK, this Rosalind Franklin rover, which you have actually seen one of the mock-ups of, one of the prototypes of. Tell us how big these rovers are, because they always look fairly small on the TV, but this one, it is reasonably big. It's about the same size as a Fiat 500 and hopefully more reliable.
They've probably got a higher top speed as well.
Yeah.
Of nearly 3 miles per hour.
Woohoo!
Yes, it is. The size of it did surprise me. I will confess, I was expecting it to be a little bit bigger. When you see the Curiosity rover that NASA's building, you see people have gone to the Jet Propulsion Laboratory and have taken pictures of this thing. It's quite a big rover. It's about the size of a Ford Focus. The ExoMars rover, the Franklin rover, is a little bit smaller. It has, on top of its wheels, it has a camera on a gimbal. It's used for giving it 360-degree vision, or not 360 degrees all at once, but it can rotate fully. And that stands at about 6 feet tall. So the wheels themselves are about 2 feet wide, and then the rover itself is about 6 feet tall. So it's a fairly chunky thing, and it's going to be powered by solar panels. So it's going to have solar power and batteries, and it'll just charge them up during the day, discharge them at night. That presents a couple of interesting little challenges. Firstly, as you charge and discharge batteries, as we all know with our mobile phones, they degrade. And so as you fill them up and discharge them, every time they're able to hold a little bit less charge. But also, it means the rover will have to shut down at night. Rovers like Curiosity, they have a nuclear battery. They have a thermal generator based on nuclear decay, which provides not only heat to the rover, but also provides electrical power. And the Franklin rover is not going to have that. The advantage there is you don't have to put a lump of radioactive plutonium on top of the rocket and anger Greenpeace when you want to go to Mars. The downside is you have to rely on the charge-discharge cycle of the batteries to actually do the experiments.
And those experiments are regarding trying to find life or signs of previous life on Mars, which is going to be hugely exciting, because in the first episode that we did of the Kielder Observatory podcast, we spoke to Professor Wallace Arthur, who's an expert on finding life in other worlds. And the actual fact of the matter so far is that to date, there has actually been no confirmed finding of any kind of life anywhere other than on Earth. We know it's out there somewhere, that's pretty much a given, but we haven't actually found any evidence of it yet. We think that there is some hidden deep in the rock on Mars. Do you think they're actually going to do it? Do you think we're going to actually find some signs of past life?
I think so. I'm cautiously optimistic about the results from the Franklin rover. So one thing we didn't know about the solar system was just how hospitable it seems to be. The better we've got at looking, the more chances we found for life to potentially exist that we found. Back in the 1970s, when the Voyager probes were doing their flybys of the major planets of the outer solar system, they discovered that there is potentially liquid ocean under the surface of Europa, around Jupiter. That was then discovered around Saturn by the Cassini mission, the ocean underneath Enceladus. We're fairly certain that Titan, another one of Saturn's moons, has liquid water underneath its surface. And while the Earth is very large compared to some of these moons, the Earth's oceans, the Earth's crust, is actually very shallow. It's very, very thin. The liquid ocean under Europa, we think, will be potentially dozens to hundreds of miles deep. The ocean on the Earth is about a dozen miles deep at its deepest. And so although the world, Europa, is much smaller than the Earth, it actually has potentially more liquid water under its surface than is on the entirety of the Earth.
Wow.
So I do think it's a little bit arrogant of humanity to hold the Earth up and hold liquid water up as this beacon of, this is such hospitable, such a lovely place for life to exist and to develop, when we don't even have the bulk of the liquid water in the solar system. And in the last few years, since about 2015-16, we've been discovering more and more pockets of liquid water under the surface of Mars. So Mars's normal surface temperature is about minus 40 Celsius. Its atmospheric pressure is about 1% that of the Earth's, and so it's not possible for liquid water to exist on the Martian surface. Any pockets of liquid water would just evaporate and freeze kind of at the same time.
Wow.
But there are ice caps on Mars. There are pockets of water that's frozen solid. And so as the Martian atmosphere thinned over the first sort of 1.5 billion years of Mars's existence, that water will have frozen and retreated back towards the poles. And we think that there was about 5 times more water on Mars in the past than is currently frozen at its poles and in its craters. So there used to be an awful lot more water on Mars than there is just now. And in the last 3 years with the Mars Express orbiter, which has been going around Mars since, I think, 2003, that has a ground-penetrating radar designed to look for subsurface pockets of water, and it found a fairly substantial lake of liquid water underground on Mars about 3 years ago. And that should have been the biggest news story of the day. I think something in the Trump administration overshadowed it. The ground penetrating radar system that the Mars Express orbiter uses, it can look a good few meters underground. And liquid water actually reflects radar waves. So the radio waves, they pass through the topsoil of Mars. All the orbiter is doing is it's listening for an echo. It's going boop, 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 and it's listening for boop, ding, an echo back. And because it's in a polar orbit, so its orbit carries it over the Martian poles, close to the poles, all of its orbital ground tracks start to overlap, and so it has better coverage of the ground near the poles. And so it's found this liquid lake. Obviously it's not exposed to the Martian atmosphere. If it was exposed to the Martian atmosphere, then the water would evaporate. But also, curiously, this lake isn't exposed to as much radiation as the Martian surface. The atmosphere of Mars does an okay job at absorbing a lot of the sun's radiation, but it doesn't absorb anywhere near enough for humans who want to go and live there, and any life forms that might want to exist on the Martian surface. The soil's just too heavily irradiated. However, because the rock absorbs radiation, absorbs the ultraviolet and X-ray photons, the high energy, high speed electrons and neutrons from the sun, that gets absorbed by the tops of a meter or so of the Martian topsoil, and so any liquid lakes that are more than a few meters underground have adequate protection. And so they're talking about when they send human settlers to go and live on Mars, while robots build the surface settlement, the surface infrastructure, the astronauts will actually live underground because it's safer from radiation.
The actual Rosalind Franklin rover, though, itself, which is what's going to be launched next year, all being well, is stacked full of all sorts of scientific kit that can do all sorts of experiments on board on any samples that it takes. It's got a big drill that drills down fairly deep, 2 meters into the surface of Mars. What are the discoveries that they are hoping to achieve with the Rosalind Franklin rover?
So the big discovery that they're hoping to make from this rover is they're looking for signs of active biological life underneath the Martian surface. So as I mentioned before, because the topsoil of Mars is heavily irradiated by the sun, it's not possible for any organic, molecular, cellular life to exist there. It would just be destroyed by the radiation. However, underground, there is that level of protection from the fact that the soil absorbs the radiation. And so the reason the rover has a big drill, I think it's just over 2 meters long, is it will be able to drill down to a depth in the Martian topsoil where any microbes that exist are protected by the soil above them. So that's what they're hoping to find. Now, when they do eventually announce, we've discovered life on Mars, the first question people are going to ask is, are you sure you didn't sneeze on the rover before you sent it up there? Mm-hmm. Now, they're taking great care to make sure that the mission is sterilized. Right now, biology is a one-planet science. We have, as we were discussing with Wallace, never found any sign of biological activity anywhere off the Earth, to the point where we're not even sure we can define what it looks like. The rover was named after Rosalind Franklin because she was, as you mentioned, the person who discovered or first theorized the structure of DNA based on X-ray measurements. And all life on Earth is based around DNA. So when they drill down, they will have chosen the place where they drill as a result of methane deposits in the Martian methane's presence in the Martian atmosphere. Methane is a gas which is very susceptible to ultraviolet radiation. If you expose methane to ultraviolet radiation, it denatures, it goes back to being carbon and hydrogen. And so it doesn't hang around in the Martian atmosphere for very long because Mars doesn't have an ozone layer offering protection to the methane like the Earth has. And so if you find methane in Mars's atmosphere, it has not been there for very long. Methane on Mars is one of these things that's been sort of back and forthing in the scientific community for years and years. There was a ground-based telescope a good number of years ago now suggested they found seasonal pockets of methane in Mars's atmosphere, but it turns out they were just badly subtracting the signal from the Earth and they were detecting methane in Earth's atmosphere. The Curiosity rover has detected pockets of methane on Mars, and this is something that the Perseverance rover is going to follow up on. It's going to be better at analysing, looking for methane in Mars's atmosphere. But Curiosity claims to have found pretty substantial levels of seasonal methane in the Martian atmosphere. And what's curious is the Trace Gas Orbiter hasn't found any. The Trace Gas Orbiter is looking specifically for methane, this short-lived molecule that's produced on Earth almost exclusively by biological organisms. The most famous source of methane on Earth is probably cows, but it's also produced by microbes. And if you found a cave or a mound on the Earth that was excreting methane, you would assume that that was due to the presence of microbes in that environment, in that mound. We have to be quite careful suggesting that any methane we find on Mars is a direct result of biological activity, but it would be a very strong indicator. And so the Trace Gas Orbiter is looking for pockets of methane in the Martian atmosphere, so far not having enormous amounts of luck finding them.
And the part of Mars that the Rosalind Franklin rover will be hopefully landing on, there's been a lot of debate between the powers that be as to where to actually land this, and they've chosen an area called Oxyplanium, which is fairly looks fairly sort of northerly, really, as to where all the other landers have been. So it's in a slightly different area to what's maybe been explored before. I think there've been other landers long time ago. I mean, the Viking 2 was a similar kind of latitude, and I think it's Phoenix in 2008, but certainly nothing recently in this particular part of Mars where they're planning on landing. And it looks like it's, as you mentioned, near the polar ice caps. It looks like it's certainly going to be a cooler part of the planet of Mars. So it'll be interesting into what that area of the planet yields when they do these tests.
There are an awful lot of different factors at play when you choose a landing site for a rover, and I'm not sure off the top of my head what the checklist for landing sites that they've chosen is going to be. So it is likely that they will have found potentially pockets of methane in this Oxyplanium, but also there will likely be deposits of permafrost near there. They'll potentially choose to land in a crater, possibly even where there is permanent shadow in part of the crater to keep water deposits frozen. And going to the sort of more extreme latitudes away from it, it's much easier to land something at the equator than it is to land it at higher latitudes, simply because the solar system is a big flat plane. And so if you send something to go and land on Mars, it's easier to hop from roughly the equator of one planet to roughly the equator of another. You don't have to expend fuel. Sorry, you don't have to, putting my cup down. You don't have to expend fuel shifting the orbit to higher latitudes. But I believe the suspicion is, if we're going to find water, it's more likely to be closer to the poles, because that's where the ice is, essentially.
And if we do get confirmation from this rover, the Rosalind Franklin rover, when it lands in 2023 or sometime after that, that we do find actual evidence of water, that we do find microbial evidence of life on Mars, just tell us how big a discovery this would be. I mean, this would be like one of the biggest scientific discoveries of all time, wouldn't it?
Yes, it would be one of those sort of civilization-defining discoveries. The discovery that biological activity, life has evolved somewhere else in the universe. Wallace and I used to have quite spirited discussions about this up at the observatory, because one of the talks I used to give at the observatory when I was there full time was about the search for life elsewhere in the universe, where we looked at the solar system, we looked at the wider universe, and something that struck me as a little bit odd was just how quickly life seems to have developed on the Earth, given all the correct conditions. So we had liquid ocean, hydrothermal vents, organic chemistry, and within 100 million years, which is nothing on a geological timescale, of the oceans forming on the Earth, we have the earliest signs of microbes developing. Incredibly short timescale for life to actually take a foothold. But then we look elsewhere out at the solar system, and we've now found liquid water absolutely everywhere. But looking further afield, looking at our own solar system, it could be the case that life is much more common than we thought. But as we look, further out into the universe, you look at Fermi's paradox. If the basic building blocks of life, heat, water, carbon, are absolutely everywhere, why don't we see evidence of civilizations filling the sky? The more we've learned about stars themselves, the trickier it seems to be for some planets to be potentially hospitable around the most common stars in the universe, red dwarf stars. So it might be that our sun, it might not be the case that the stars have Goldilocks zones, regions where just as a result of the heat output from the star, the world has enough heat to maintain water as a liquid. We have most of the water in the solar system is 5 times further out from the sun than the Earth is, under the surface of Europa. So the Goldilocks zone, in my opinion, might not be a very good indicator of where we could find liquid water, potentially find life in the universe. It might be that there are Goldilocks stars, like our sun, that have just the right balance of heat output to radiation output. So with a red dwarf star, they're much more magnetically active than our sun. Because they're colder, the planets have to be much closer in, and so they're exposed to not only much stronger tides, which could tidally lock the planet to their star, but also much stronger radiation conditions, because red dwarfs emit far higher levels of ultraviolet and X-ray radiation by flares, and also they emit far more protons and electrons in their solar winds, which will just pummel the atmosphere of any planet around that red dwarf star.
It's just about having the right balance in the right place at the right time, really, isn't it, for all the ingredients to mix right? But it's fascinating to think that there is definitely life out there. It's just that we haven't yet, even though we feel that we're an advanced civilization, we haven't actually got that knowledge of the universe that we really need yet. But we will find life, possibly in our lifetimes.
We've not been very good at looking up until this point. We're only just at the beginning of our ability to study these other worlds in great detail. We've only had rockets, the ability to go there for the last 60, 70 years. When we developed the ability to go to Mars, to go to Jupiter and Saturn, to explore their moons in more detail, to explore the surface of Mars in more detail, almost every month we discover something that makes the solar system seem far more hospitable than we initially assumed. And so I'm very optimistic that within the next few years, the results from these rovers is going to come back, and we are going to discover that we are indeed not alone in the universe, and microbes are absolutely. I think microbes are going to be absolutely everywhere.
So that's us looking for signs of other life elsewhere in the universe. And one point that Professor Wallace Arthur made in that first episode, which if you haven't checked out yet, and this kind of stuff fascinates you, you must listen to it because it's mind-blowing, the stuff he was saying about other life. I mean, one point he made was that whilst we haven't found life yet, other life will almost certainly have found us by now.
Yes. Well, the Earth is a surprisingly difficult planet to find. When we talk about finding other worlds, there are a few techniques that we use. The most famous of these is called the transit method, where you analyze the light from a star, and if a planet passes along your line of sight, passing between you and the star, then it will block out a small amount of the star's light, and it will appear to get a little bit dimmer. But the amount of light that gets blocked is a minuscule portion. The area of a circle is pi times the radius squared. And so if you have a planet that's a planet that's half the diameter of a star, then it will block out a half squared, or a quarter of the star's light. If the planet is a tenth the diameter of the star, it'll block out only 1% of the star's light. And that's the size of Saturn compared to the Sun. The Earth is only 1% of the Sun's diameter. So it would block out less than 1% of 1% of the Sun's light if you were an alien looking at our solar system trying to detect the Earth. But also, you would have to be in a strip of the universe where you are sort of within half a degree of the Earth's orbital plane in order to actually detect the Earth. If you're more than half a degree out, because that's the width of the sun from us here on the Earth, we see it as about half a degree wide. If you're beyond that, if you're above or below the orbital plane of the Earth, then the Earth would just pass above or below the sun from your line of sight. You'd never detect this tiny planet. So there are very few stars in the Milky Way galaxy that could actually look at the sun and detect the Earth using the transit method.
Basically, we're just very good at intergalactic hide and seek. Hayden, it's been fantastic speaking with you. Thanks for joining us. So before you go, on the subject then of life on Mars, a subject that you are a bit of an expert in, what do you think life on Mars will have looked like when it's all boils down and we get the evidence that hopefully we're hoping for? What do you think it's going to show that life on Mars was like?
So my hunch would be that life on Mars never, if it did ever develop and evolve, it would not have got beyond the microbial stage. I don't think we could expect to find anything more complex than single-celled organisms on Mars. The other ocean worlds of the solar system, Europa, Enceladus, Titan, I think the story might be a little bit different. But specifically Mars, I think would have stuck at microbes because of how few places there, on the surface there is water. There's not an awful lot. I think the largest liquid water deposit that we found on Mars is only about the size of Loch Lomond.
Here's what I found.
Oh, sorry, Siri. So I think when we look at the history and evolution of life on Earth, it took only 100 million years or so between the formation of the oceans and the development of the earliest biological organisms. For 3.5 billion years, until only about 500 million years ago, all life on Earth pretty much was microbial or plant-based. It's only in the last 500 million years that multi-celled organisms, insects, birds, us, dinosaurs, have come about. And I think given how inhospitable Mars now is, any surviving pockets of life will still be in that microbial phase, living in the soil. But that's just my gut instinct.
We'll find out if that gut instinct is confirmed or not, hopefully, in the next few years. The next part of the ExoMars mission due to blast off in 2022. It'll be the 20th of September 2022, landing, hopefully, in one piece on Mars on the 10th of June 2023. So we may just be a few years away from getting confirmation that there was indeed life on Mars. My thanks to Hayden Goodfellow for joining us to explain more about the mission to Mars and what life may well be like if we ever set foot on Mars in our lifetimes. It is indeed possible. Thanks also to Dan Pye for bringing us up to date with the latest from Kielder Observatory. And if you'd like to follow us on our social media channels, you too can find out the latest as it happens from Kielder Observatory, because whilst the public are not allowed in at the moment, we do have staff up there from time to time able to share images of what's been happening in the night sky and the surrounding area. So follow us, Facebook, Twitter and Instagram, and you can check out the latest at our website as well, kielderobservatory.org. In the meantime, please stay safe, take it easy, and we'll speak to you on the next episode of the Kielder Observatory Podcast. Goodbye.